7.4 Integration of rational functions by partial fractions. In this section, we show how to integrate any rational fraction, a ratio of polynomials, by expressing it as a sum of simpler fractions called partial fractions that we already know how to integrate. To illustrate the method, observe that by taking the fractions 2 over open x minus 1 close and 1 over open x plus 2 close to a common denominator, we obtain 2 over x minus 1 minus 1 over x plus 2 equals 2 open x plus 2 close minus open x minus 1 close over open x minus 1 close open x plus 2 close equals x plus 5 over x squared plus x minus 2. If we now reserve the procedure, we see how to integrate the function on the right side of this equation. The integral of x plus 5 over x squared plus x minus 2 dx equals the integral of open 2 over x minus 1 minus 1 over x plus 2 close dx equals to the natural log of the absolute value of x minus 1 minus the natural log of the absolute value of x plus 2 plus big C. To see how the method of partial fractions works in general, let's consider a rational function. F of x equals big P of x over big Q of x, where big P and Q are polynomials. It's possible to express f as a sum of simpler fractions, provided that the degree of big P is less than the degree of big Q. Such a rational function is called proper. Recall that if big P of x equals a sub n x to the power n plus a sub n minus 1 x to the power n minus 1 plus ellipsis plus a sub 1 times x plus a sub naught, where a sub n does not equal to 0, then the degree of big P is n, and we write degree of big P equals n. If n is improper, that is, degree of big P is greater than or equal to degree of big Q, then we must take the preliminary step of dividing big Q into big P by long division until a remainder big R of x is obtained, such that degree of big R is less than degree of big Q. The division statement is equation 1, f of x equals big Q of x over, f of x equals big P of x over big Q of x equals big S of x plus big R of x over big Q of x, where big S and big R are also polynomials. As the following example illustrates, sometimes this preliminary step is all that is required.